Welcome back. We're moving right along, still in Module 3, Topic 2, Lesson 2, and we are on the Introduction and the Getting Started, page 413. Okay, so it says double talk, solving one-step addition equations, and that happens to be one of our terms as one-step equation as well as inverse operations. So learning objectives, learning goals, reason about addition equations, use double number lines to represent and solve one-step addition equations. Use inverse operations to solve one-step addition equations. Determine each sum or difference, 5 and 67/100ths plus 8 and 73/100ths. See if I can get this a little bit more clear. Okay. So we're just adding these, and remember when you add decimals, you line up the decimal. Same with the subtraction. So 7 plus 3 is 10, carry a 1. 1 plus 6 is 7, plus 7 is 14. Decimal stays in line. Carry the 1. 8, 5, and 1 is 14. Okay, excellent. And now we have the subtraction. 8 and 73/100ths minus 5 and 67/100ths. We can't do 3 minus 7, and you can't just go backwards, 7 minus 3. You have to regroup, so that 3 is a 13. The 7 is now a 6. 13 minus 7 is 6. 6 minus 6 is 0. Decimal stays in line. 8 minus 5 is 3. We could check that real quick with addition, which happens to be the inverse operation of addition. We could just add it. And there we go. We are correct. Okay, number 3. So 3/7 plus 4/5. In order to add fractions, we need common denominators. So our common denominator for 3/7 and 4/5. I'm going to write it. Let me rewrite this here. 3/7 plus 4/5. So a common denominator for those two would be 35. They're both prime numbers, so they don't have any factors in common. So to get the least common multiple, I need to just multiply them together. So 7 times 5 is 35. So I'm scaling up by 5. So I need to do the same thing there. So 3 times 5 is 15. Here I'm going by scaling up by 7. So 4 times 7, 28. You do not have to draw those arrows if you can just rewrite the equivalent. And then 15 plus 28. 5 plus 8 is 13. I would be carrying a 1, so 43 over 35. And I'm okay if you leave the final answer like that. Okay, 20/3 minus 15/4. So our common denominator is going to be 12. They don't have any factors in common, 3 and 4, so we have to multiply them together. We do 3 times 4 to get to 12, so we're going to do 20 times 4, which gets us 80. We do 4 times 3, so 15 times 3 is 45. And then we're going to subtract. Remember, the denominator stays the same. If you can't do 80 minus 45 mentally, it's not a big deal. And you certainly don't need a calculator to do this. And there we go. 35/12. Okay, moving on. If you did want to turn that back into a mixed number, how many groups of 12 can we get out of 35? That would be 2 whole groups. 12 times 2 is 24. 24 from the 35 would mean that there'd be 11 out of the 12 left. Okay, getting started. The open road says this double number line shows 3 equivalent equations. So we have 0, and then we have 3, 6, and 12 here. We have n plus 2, n plus 5, and n plus 11. So it's trying to show us that 3 and n plus 2 are equal. So it says write the equations represented. So that's one of them, n plus 2 equals 3. This one would be n plus 5 equals 6. And finally, n plus 11 equals 12. So what is the value of n that makes all of those true? This one's pretty obvious. I'm sure you guys all already know. It is 1. 1 plus 2 is 3. 1 plus 5 is 6. 1 plus 11 is 12. How can you check that the value you determined in question 2 makes the equations true? We can do that by substituting, which is what I just worked us through. Verbally, I'll write it down. So this was n plus 2. So wherever the n is, we put the 1. This was n plus 5 equals 6. Wherever the n is, we put the 1. So here we do get 3 equals 3. Here we do get 1 plus 5 equals 6 equals 6. And then we have n plus 11 equals 12. So 1 plus 11 equals 12. And 12 equals 12. Okay, we'll see you on the next video.